Hey there guys, and welcome to this video on condensation polymers and condensation polymerization. Okay, so first you need to know what condensation polymerization is and how it differs from addition polymerization, which is the other style which you have looked at. You also need to understand the different types of monomers which you are allowed to use in order to form a condensation polymer, right? Not all kinds of monomers will be able to form a condensation polymer, so we need to have a look at which ones are able to do it. Finally, we're going to have a look at an actual example, and then you'll be able to do more like that yourself. So let's dive straight in right now. Right, so a condensation polymer is formed when monomers join together, right, via a chemical reaction, that's obvious, and release a small molecule as a result. Okay, now that small molecule, because this sounds like a bit of a mouthful, basically it means when monomers join, rather than in an addition polymerization where they just join up and that's it, normally what they do is they kick out H2O, right? So that small molecule is H2O generally. Okay, so you're going to be getting rid of H2O every time monomers join together, and we'll have a look at an example of that. Now, the monomers must contain two functional groups, okay? Two functional groups, so that they can form a chain. Now, those two functional groups could either be the same or not, right? And we're going to have a look at an example right now. So, let's have a look. Now, if you don't know what a carboxylic acid or an alcohol is, now stop the video, go and have a look at my videos on those, because that is extremely important. You need to know what those functional groups actually are. Right, so if you have two monomers that look like this, well, if you've got, and by the way, X and Y just stand for literally anything. So it could be like 10 carbons in between, or it could be 2 carbons with some hydrogens and some chlorines or whatever, right? The point is you don't care. What you care about are the functional groups on the end. And if you have what we call a dicarboxylic acid, which means a molecule with 2 carboxylic acid groups, so 2 COOH groups, and a molecule with 2 alcohol groups, or 2 OH groups, right? We call that a diol. And so 1, 2, right? Then those things are able to join up. Because if you think back to the video on carboxylic acids, a carboxylic acid plus an alcohol makes an ester, right? Those things are actually able to react and combine. And so let's have a look. Boom. What you do is the OH on the carboxylic acid and the H on the alcohol actually disappear to form water, and that's what we were saying before about releasing that small molecule. This happens every single time. And so what you get is this molecule here, right? Notice that this is your ester bond, right? The COO of the carboxylic acid and the O of the alcohol, right? That is your ester bond, and now we've got these things having joined up. But now notice, I'll just draw it in a different color. Notice that we have a carboxylic acid group on one side, which can now react with another alcohol, and an alcohol group on the other side, which can now react with another carboxylic acid, right? So this could actually go on indefinitely, hence why this is a polymerization. Okay, so condensation polymerization, right? An alcohol group and a carboxylic acid group join or react with each other to form polyesters, right? The polymer is called a polyester because it's loads of esters, right? Polyesters can be formed using a single monomer as well, right? Which contain only one alcohol group and one carboxylic acid group. Yeah, and we'll have a look at that in a second. Finally, polyamides, we haven't mentioned these yet, are made by reacting carboxylic acid groups with amine functional groups, right? NH2 is the amine group. It reacts in a very similar way to the OH alcohol group in that it can react with a carboxylic acid. Right, so let's move on and actually show what I just mentioned, where you could have a molecule which has one alcohol functional group and one carboxylic acid functional group. So look, basically, this molecule has an alcohol group on one side and a carboxylic acid group on the other side. It can actually react with itself. Notice that this molecule is exactly the same. And so the OH of the acid and the H of the alcohol would basically be released. And so what you'd get is this carbon joins to this oxygen in an ester bond. And boom, there we go. And you would kick out your H2O like so. Okay, and so that is absolutely fine. Now, let's have a look at the polyamide example. A polyamide can be made in just the same way as we saw previously, except you replace the alcohol with an amine, right? So a diamine in this case. Okay, so if you react these two together, what are you going to get? Well, in exactly the same way, the OH group of the acid and one of the hydrogens of the amine group are going to disappear, right? This, by the way, is exactly the same as the reaction that's happening with amino acids, right? An amino acid has one amine group and one carboxylic acid group. If you want, go and have a look at the video on amino acids and proteins, because this reaction is covered in that as well. Anyway, what's going to happen? Boom. Those are going to bind. Notice the nitrogen still has another hydrogen, right? And that's the difference between this and the OH group, where the hydrogen disappears and then you've got an oxygen on its own. Nitrogen still has a hydrogen, but the reaction really is exactly the same. And you get water given off just as before. And so that is all well and good. So now, pause the video for a second and try and draw the polymer we would get if we added together N. Let me just draw it in a different color. If we added together N numbers of the following monomer. Now this is a monomer which contains one carboxylic acid group and one amine group, so it can actually react with itself. Pause the video for a second, have a go at that. Okay, welcome back if you did have a go. So what we're going to get is the following. So basically your carboxylic acid group, okay, is going to react. So this OH is actually going to disappear, right? So you're going to get this binding to the nitrogen on the next monomer, right? So that's why we draw the brackets around it. Then you've got whatever's in the middle, X, and then you've got nitrogen, hydrogen, right? And then that is binding to the carboxylic acid group on the next monomer. And so this is what we get. This happens N times. So we get N number of these. And every time we do, so every N time that we do, we also get a water molecule. So you also get NH2O as a result. Okay, perfect. So we are going to stop there. I hope that made a whole lot of sense. Please comment in the box below if you have any questions or any suggestions. But as usual, please like and subscribe, because that really does help me out, and you'll be notified whenever new videos become available. But thanks very much. Look forward to seeing you in the next video.